All right, today we are diving into something truly radical. It's an engineering philosophy that completely flips the script on high altitude drone recovery. So forget everything you know about fighting gravity. We're about to explore a system that's designed to surrender to it and, believe it or not, become way more powerful in the process. Let's get into it. This one sentence from the source material really says it all. It captures the entire paradigm shift. This isn't about building a better parachute or stronger motor. No way. It's about creating a system where the very act of falling generates its own control. It's a fundamental change in how you even approach the problem. And to really get why this is so revolutionary, you've got to look at the old way of doing things. For decades, right, getting a UAV back from high altitude has been seen as this brute force problem. It's just a constant energy-draining fight against the inevitable pull of the Earth. I mean, think about it. You've got propellers screaming, batteries just draining away, flight controllers working overtime, all just to slow the vehicle down. This whole approach, it's not just inefficient, it's incredibly fragile. It makes the drone super vulnerable to high winds and turbulence, all while burning through the very energy it needs for its actual mission on the ground. And this slide just lays it all out perfectly. On one side, you've got the old school, resisting gravity. That means high energy, constant active propulsion, and it's super sensitive to wind. But on the other side, you have this new philosophy, embracing gravity. And that path, it's low energy, uses passive control. And get this, it leverages high momentum to its advantage. It's a complete inversion of the traditional mindset. So how in the world did they build this? Well, the solution isn't just some technical tweak. It's a full-on philosophical breakthrough. The source material calls it the Untergang, which is a German word that can mean downfall, but here they've reframed it as something strategic, something powerful. Okay, so here's the crucial part. Instead of fighting to stay upright, the vehicle intentionally flips upside down. It goes into this near-passive state, and in doing so, it basically turns itself from a fragile aircraft into a highly precise kinetic object. It's using its own fall to its advantage. It stops being a victim of gravity and starts mastering it. Now, what's really fascinating here is how the numbers totally back this up. Just look at the comparison. Energy consumption goes from high to low, because the system is actually harvesting energy as it falls. Descent velocity goes from being restricted to near terminal, and wind sensitivity, it just plummets, because the vehicle's high momentum makes it incredibly stable. It's a clear win right across the board. So, this brings us to what is easily the most counterintuitive and honestly brilliant part of the whole design, how the system literally creates its own power, just from falling. It's not magic, I promise you, it's just incredibly clever aerodynamics. So here's the breakdown. As the inverted drone falls, the air rushing up from below pushes through the rotors, spinning them just like a pinwheel. And that auto-rotation is actually enough to power the flight controller, keeping the drone's brain online without touching the main battery. The system takes what would normally be a destructive force, that high-speed airflow, and turns it into useful operational energy. It's genius. And the payoff for this is enormous. By not wasting all that power on the way down, the drone arrives at its target altitude with a full battery, totally ready for the most critical part of the mission. It preserves its energy for when it really matters, which completely changes the calculus of what these vehicles are capable of. But wait, if you're going to descend that fast, you have to solve a massive and often catastrophic problem in aerodynamics. Anyone who's flown a quadrotor knows that coming down too fast can be a death sentence, all because of something called the vortex ring state. The source calls VRS the mirror crypt, which is just a perfect description. The rotor gets trapped in its own turbulent air, and it creates this donut-shaped vortex that completely kills its lift. The drone essentially starts falling through its own dirty R, and boom, you lose all control. For a system that's based on falling fast, this is enemy number one. So how do you beat it? Well, the solution is just so elegant. It's called yaw rate modulation. The flight controller makes the entire aircraft spin or yaw really fast. This constant rotation means the rotors are always moving sideways into clean, undisturbed air. They never get a chance to get stuck in their own wake. It effectively shatters that mirror crypt before it can even form. And the result of this incredible innovation? A descent velocity that is 3 times faster than what's possible with standard maneuvers, all without any loss of control. Let me say that again. 3 times faster. This isn't just a small improvement, it is a massive leap in performance, turning a dangerous limitation into a tactical advantage. Okay, so now let's zoom out a bit. This technology is incredibly impressive for just one drone, but its real strategic power, that's realized when you apply it to an entire fleet. This is where individual efficiency scales up into collective dominance. The system actually uses principles from flocking behavior, like you see in birds, to coordinate the descent of multiple drones at once. They don't just fall randomly. They perform a synchronized ballet on the way down. The source calls this the chorus of the deep. And just like voices in a choir, the individual drones act in perfect harmony to achieve a single goal, synchronized arrival. And what's the result of that? Well, the source describes it as an ice storm, a sudden, overwhelming wave of activity that appears seemingly from nowhere. Instead of a few drones trickling in one by one, you get a synchronized mass arrival from a near-silent, high-speed descent that makes conventional detection pretty much obsolete. All right, so let's just boil this all down. What are the key breakthroughs? First, you've got a 3 times velocity increase, made totally safe by yaw rate modulation. Second, you have energy harvesting, which literally turns the fall itself into a power source. And third, you have built-in stall resistance, making sure the drone can safely pull out of its dive. These 3 pillars create a truly revolutionary system. And that brings us to the final thought. This whole explainer has been about redefining a really fundamental concept. We have always treated falling as a failure, right? Something to be avoided at all costs. But this technology reframes it as a source of power, of speed, of stability. So I'll just leave you with this question. Once you've engineered the fall and it's no longer a failure, what else becomes possible?